Today we're going to talk about sets of numbers or classifying numbers. The best way I like to think about this topic is it's kind of like how we classify animals. So if you imagine the real numbers as every single animal out there, we can actually subdivide them into different groups. So we do this with animals all the time where we say, oh, we have all these animals, and then we have a smaller group which might be mammals. And you might even have a smaller group of that, which might be dogs. And then you might have a smaller group of that, which might be golden retrievers. So it kind of is like this idea of we have this all-encompassing thing, and the different groups slowly fit into them. And it works the same way with numbers. So all the numbers we can think of are called the real numbers. And there's two major groups of real numbers. There's the rational numbers and the irrational numbers. Now, rational numbers, right here, is the largest group, and it's any number that can be written as a fraction. Okay, so obviously fractions can be written as fractions. Decimals can be written as fractions because that could be 63 over 100. So we could see that that would be written like that. So that can be written as a fraction. And these repeating decimals, these decimals that go on and on and on and on forever, but they're the same two numbers like 1, 2, 1, 2, 1, 2, 1, 2, which is denoted by this line, can also be written as a fraction. I don't know what that one is as a fraction, but you can see this with 0.3 repeating. That's the same as 1/3. So any of these numbers, a fraction can be a fraction. 0.63 is a decimal, a terminating decimal, so it can be written as a fraction. And something that repeats can be written as a fraction. Okay. The second largest group is this irrational group. This is anything that can't be written as a fraction. And really what that means is it's a decimal that goes on forever and doesn't repeat. As you can see, we got 1, 0, 0, 1, 0, 0, 0, 1, 0, 0. So the numbers of zeros in between keep increasing. Another example that we could put in the irrational group would be something like this. It keeps going on and it doesn't repeat. Pi is 3.1415, whole bunch of numbers that don't repeat. Radical 3, if you see that, would be 3, and then we take the square root, whole bunch of numbers that doesn't repeat. So irrational is anything that's not rational or anything that can't be written as a fraction. So now we have, let's focus again on the rational numbers. So these are anything that can be written as a fraction. There's subgroups of these rational things. Just like the example of mammals, you have a subgroup of dogs. So in this one, our subgroup is our integers. Integers are any number that doesn't have a decimal. So any number that doesn't have a decimal that's positive or negative. And so that is the integers. Any integer is also irrational, because I could write these all as fractions, but because it's a more specific group, it's got a more specific name. The whole numbers are any group that is not negative, that doesn't have a decimal. So it's all the normal numbers that you worked with in elementary school, like 0, 1, 2, 3, 4, 5, ... It goes on forever. The natural numbers is that same group, just without 0. We don't really use this a lot or even worry about this a lot. So these are the main things we're going to kind of focus off. And you can see inside the rationals are the integers and the wholes. We're going to do a couple examples and kind of see which group they fall into. So here we go. Let's take the number 5. Well, the number 5 is a non-negative number that doesn't have a decimal, so it is whole. Well, if it's a whole number, it's also an integer, because we could see 5 can fit into this. And it's also going to be rational, because you could have wrote that as a fraction as 5 over 1. So 5 would fit all of these categories. Let's try another example. Okay, now we have negative 3 over 5. Well, it's not going to fit whole because it's a negative number, so it's not a whole number. It's not going to fit the integers because this is a fraction or it has a decimal afterwards. As you can see, if we did 3 divided by 5, we get the decimal 0.6. So it's not an integer. It is a fraction, So it is only rational. Let's try another one. Okay, the square root of 17. It's not a whole number. It's not an integer. It's not rational because when you check out the square root of 17, and a lot of times I like to do this on my calculator just to see, we can see this is a number that does not repeat and does not stop. So this would fit our irrational category because it's a decimal that doesn't repeat and doesn't stop. Let's try another one. Okay, so this is definitely an integer, which means it can be written as a fraction, so it's also rational. Let's try one last example. Now, the biggest mistake I have a lot of times with a problem like this is most people go, oh, this is rational because it's a fraction, and they don't look at these other two categories. But you should always see if you can divide this thing into a nice number, because then it might fit one of these other categories. Well, negative 10 divided by 2 is negative 5, and we just learned from the other one that this is an integer, and it is also rational. So if you can divide, you want to divide this thing out. Okay? So that's how the sets of numbers works. You have a lot of problems on that. In this next example, really fast, we're going to look at how we round numbers. Okay, so now we're going to talk about rounding. And there's a couple interesting things about rounding. First, I just want you to know like our place values so we can talk about where these numbers are located. Take this gigantic number that I've written. How they do place values is it's always based on this decimal. So wherever this decimal is, we kind of make our place values off of it. So this is our ones place, this is our tens, this is our 100s. If we keep going on, we get a thousands out here, and we can keep going that way. Well, on the other side of the decimal, they want to do the same thing. So they would call this our tenths, this our hundredths, this our 1,000ths, then this would be our 10,000ths, and our 100,000ths, then our millions, then our 10 millions, then our 100th millionths. So everything on the right side of the decimal, they add this little th to it to denote it's a smaller number, it's tinier. And everything to the left of our ones place or left of our decimal gets denoted as it's just the normal number like tens, hundreds, or 1,000s. So if we're going to round to the nearest tenths, the first thing that we really want to do is figure out where the tenths place is, because that's the number we need to keep. And our tenths place is this 1. And then once we decide we have to round it, we want to know, are we going to round the 1 up, or are we going to keep the 1 the same? So really we're rounding up or we're keeping the same. We decide that by if the number behind the place that we're keeping, so we're keeping the tenths place, the number behind the place we are keeping, we decide on that, is that bigger than 5 or less than 5? Well, that is less than 5. So if it's less than 5, we just keep the number the same, and that would be the answer rounded to the nearest tenth. We're going to try the same number again and round to the nearest 100th. So now we're going to try to round this number to the nearest 100th. So again, we want to find our hundredths place. So our hundredths place is this 3 right here. And then we're going to choose the number behind it to decide everything. So the number behind is a 7. So that is going to tell me, since it's larger than 5, to round this thing up. And so when I round this thing up, I'm going to get 1, 4. And that would be my answer. Let's try one last example where we try to round it to the nearest 1,000th. First, again, we're going to find our place. So, again, tenths place, 100ths place, 1,000ths place. So that's the number we're making a decision on. We look to one number after it. So the number after it is an 8. That is larger than 5. So we'd have 128.138. And this would be our final answer if we needed to round to the nearest 1,000th. So on rounding, always check the place and then round. Look at the number 1 past it to see if you're going to round up or keep it the same.